Ignite Boulder! Woo! My name is Matthew Arnold. I am very, very excited today to talk with you about a novel approach that the lab I'm working with, the Behavioral Neuroendocrinology Lab at the University of Colorado, is designed for the treatment of depression. So, depression. In the US, more than 40 million adult Americans are on antidepressant medications. That's 1 in 6. Depression carries the second largest disease burden in the world. When investigating depression, we first have to understand how antidepressant medication works. So in the lab, we investigated how drugs like Paxil, Zoloft, Prozac work, and once we figured out that area in the brain, we then went to the research and we found that there are other stimuli that also activate that same part of the brain. And it turns out that warm ambient temperature like that of a really hot sauna also activates the same part of the brain that's activated by antidepressant medication. And we thought, well, that's interesting. Could it be that depression and thermoregulation or sweating is somehow related to each other? So then we kept on doing our research. And what we realized is the people who have depression have increased body temperature relative to their normal counterparts. We thought, that's kind of interesting. Another part of evidence, we found that although people with depression have increased body temperature, they have a decreased sweating or skin conductance. So increased body temperature, yet they don't sweat as much. And it's been shown that with 95% accuracy, we can predict whether somebody has major depressive disorder based solely on their body temperature and skin conductance. Wow, right? So taking this a step further, the number one side effect for antidepressant medication is an increased sweating. So somehow, the thermoregulation system is associated with antidepressant medication. We then took this idea a step further and thought, well, maybe, just maybe, antidepressant medication activates the brain, but perhaps it also activates the body as well. And like scientists do, we took things a step further and thought, well, maybe it's possible to just activate through an alternative stimuli in the body, and maybe through some crazy mechanism, will activate the part of the brain that is ultimately activated by antidepressant medication. So then we found the Herkel HT3000 hyperthermia inducing machines, and woo! And like scientists do, we ran a clinical trial in the Netherlands, because IRB approval is easier. And, no, get this, a single bout of treatment, 2.5-hour bout, and it helped depression symptoms for more than 6 weeks. 2.5 hours. Well, now we're left to explain this. So taking an evolutionary approach, why would it make sense that we have a circuit activated by warm temperature that would alleviate depression? So here's kind of the current thinking on this idea. Imagine you're sitting in your cave, and perhaps there are certain aspects of depression that could be beneficial. You're doing a lot of rumination. While doing a lot of rumination, you're not using extra calories. So in places in which food calories are at a shortage, this might be beneficial. However, imagine the sun comes beating down and your cave gets too hot for you to regulate your internal body temperature. Wouldn't it make sense that you would have a circuit in your brain that would turn on, that would change that rumination, that internal rumination, to active engagement? So we think that that's kind of what's happening through this stimuli. And maybe depression is just a result of not getting a powerful stimulus in order to shift your brain from that rumination to active engagement. So maybe depression is just in this cave. And I feel like I want to make a reference to waiting for a black hole sun. Right? Thank you guys so very much. And I have to thank my lab, the Behavioral Neuroendocrinology Lab, as well as lots of other people. that have played a role in this project. You guys are awesome.